Guys, we are going to do a wonderful introduction to equations. Video is going to keep it nice and sweet and simple. It's just the introductory stages, but I promise you the concept holds true for even the problems that seems more challenging. So when you think about equation, here's what I want you to think about first. First, you got to think about we're going to solve for an unknown. So a lot of you just, as soon as you see x in a problem, whether it's an expression or equation, you're like, oh, gotta solve. But here's your opportunity. Or when you're talking about math, you're like, oh, we gotta solve that problem. And I'm always correcting students, no. You're either, especially when you're doing algebra, you're either evaluating, simplifying, or solving. You're not solving every problem. You evaluate and you simplify expressions, but you solve equations. All right? You solve equations. So think solve. Next thing I want you to do is think opposite operation, and you'll see what I mean. So think about opposite operation. I call it. All right? So whenever you're thinking equations, solving for an unknown, think opposite operation. Then here's how you think. What you do on one side, you must do to the other side. That makes it balanced, right? Because we're doing an equation. Equation means equal to, it has to balance. All right. Also, now you got it. Last thing I need you to think about, just for now, is that when we're working with expressions, we do the order of operation, right? You call it PEMDAS and Sally, blah, blah, blah. But when we're operating on equations, we do the inverse order of operation. So we do the inverse order of operation, right? So for expressions, you start with your factors first. That's what your parentheses and your exponents and your multiplication and division. And then we operate on terms, which is your addition and subtraction, right? So, but when we're working with equations, we are going to work on our terms first, and then we're going to operate on our factors, okay? And I'm going to show you an example of that. So, let's begin. Let's just do some really simple equations. I want you to watch the pattern here. So here I'm going to be solving everything. So I'm going to try to solve for x. I'm going to use your favorite variable x plus solve for x in the given equation x plus 2. So look what I'm going to do here. I'm going to subtract 2 from both sides. So these two cancels because plus or minus gives you 0. So I'm left with x equal 4 minus 2 is 2. So that's my equation looking for x when I have x plus 2. So look what I'm going to do here for this next. So now I'm going to be asked to solve for x when it's x minus 2 equal 4. So you can write it like vertically. You can do your operation vertically, or you can do it horizontally. So I have an x minus 2. I'm going to add 2. All right, bam, bam. So I'm left with x equals 6. All right, and now here I have another problem. I have 2x is equal to 4. I need to solve for x. So what I'm going to do, I'm going to divide both sides by 2. So I have x equal to 2. And here I'm going to have my equation, which says x over 2 is 4. So, or x divided 2 equals 4. So I'm going to times both sides by 2. So x equals 8. And then I'll have a problem that may look like where I'll have like 2/3 of x is equal to 4. All right, so what I'm going to do is that I am going to times both sides by the reciprocal. All right, so this cancels, so x is equal to, I can say 12 over 2, which is 6, right? That's what I can say, 12 over 2, which is 6. Or I can say 2 and 4 has a common factor of 2, so I'm left with 6, right? So x equal 6. So what's happening here? What's happening? Here we had the term x being added to 2. So what I did is I did the opposite operation to what you do on one side, you must do on the other side. You must do on the other side. So I did the opposite operation to both sides, and the opposite operation of that addition was subtraction. Here, the term 2 was being subtracted from x. So again, I did the opposite operation to both sides by adding 2 to both sides. So x is 6. Number 3, we had 2 multiplying x. The factor 2 was operating on x. So the opposite of multiplication is division, and I did it to both sides. So x is 2. Here we have the factor 2 dividing x. So I did the opposite operation to both sides, and my value for x is 8. Now, here's a little caveat. This can be looked at two ways. This is either 2/3 x equal 4, or I'm going to make a little space in the middle here, right? Or we can say it's 2x over 3 equal 4. So in this case, to keep things simple, whenever you have a fraction as a factor times your unknown, you can multiply that factor, that unknown, by the reciprocal of that factor. And remember, because the reciprocal is the opposite, right? It's the inverse of that fraction. Opposite operation, what you do on one side, you must do to the other side, okay? So the opposite of 2/3 is 3 over 2, and that's how come I get my x to equal 6, because I multiply it to both sides. Or I can say, well, we have the factor 2x over 3 equal 4. So I can start by getting rid of the most obvious factor, which is 3. So I can times 3 by both sides, right? See, that cancels. So I have 2x equal 12. And my x is still not solved for. So my factor 2 is multiplying x. And I can do that by do the opposite operation by dividing it. So x equals 6. So as you can see, 3 was times the 2 and 2 was divided. So that's the same as saying the reciprocal 3/2. So you can look at that either way. Now, let's look at when we have to use the inverse operation. So let's say, for example, we have 2x plus 4 equals 8. Okay, let's take a look. This is how we assess our equation. First step is identify what is affecting our unknown from being by itself. And when I say what, when I use the word what, I want to define it. What terms or factors? Right? That's what I mean when I say what. What terms or factors is affecting my unknown x from being by itself? So if I look at this equation, I see that I have the term positive 4 that's affecting x from being by itself. And I have the factor positive 2 that's affecting x from being by itself. And what I want to do is I want to operate on these terms and factor in the inverse order, right? See, remember for expressions, we usually do the order of operation, which is we take care of our factors first, P, E, M, D, PEMDAS, okay? And then we work on our terms. But when we're working with equations, we operate on our terms first, then our factors. So what we want to do here is we want to get rid of our term 4 first, and then we'll get rid of our factor 2. So again, we're going to use that OO word. We're going to use the opposite operation, and that's a positive 4. So the opposite would be a negative. And remember, what you do on one side, you must do to the other side. It doesn't matter if you set it up horizontally or vertically. So now I'm left with 2x equals 4. And I would like to get rid of my x is still not isolated. That 2 is being multiplied. The opposite of multiplication is division. So x is 2. Let's do another one which students often confuses the difference between terms and facts. So let's say we had a negative 2x minus 4 equal negative 8. All right, let's just use all negative terms and factors. So first thing I need to ask myself, what's affecting my x from being by itself, right? And as I can see, my term is negative 4. I'll just use t for term. And my factor, f for factor, is negative 2. Okay, so remember we're going to work using the inverse order of operation to get rid of our, that means term first. We work on our terms first, then our factors. That's the inverse order of operation. Okay, so here we go. So I'm going to do the opposite operation of negative 4, which is positive 4. What you do on one side, you must do to the other side. So negative 2x equals to negative 4. Because we add unlike terms with unlike signs, you subtract, keep the sign of the greater magnitude. Now, students are very tempted. Sometimes they divide by a positive 2 because they're treating the negative 2 factor, it's a factor, as a term and using the opposite of a positive, and they're simultaneously dividing and using opposite signs. But you got to be very careful. That's why it's always important, I tell students, when starting out in learning how to solve, just identify your term t and your factor f, and then you know that here you can only be adding or subtracting, and here you can only be multiplying or dividing. Okay, so here, what is my factor? You see, my factor is negative 2, not 2. So I'm going to be dividing both by negative 2. And what we know when we're dividing factors, or when we have factors with like signs, the answer is always positive. So there we go. These are just simple ways of solving equations. So let's look into your book to see what your book has. Let's see your text. Oh, really, really simple. Here we go. What are we going to do with that 3? You guessed it. We're going to subtract it from both sides. What are we going to do with that 4? You guessed it. We're going to add it to both sides. What are we going to do with that 1? That's correct. We're going to subtract it from both sides because it's positive, right? And this is asking you to solve and check. Basically, what they're saying is once you find a value for x. So in this case, it looks like x would be 5, because if I subtract 3 from 3, it cancels, and if I subtract 3 from 8, I get 5. So x is 5, and if I substitute 5 back into this equation, I'll see that 5 plus 3 is 8, right? So these are just simple ways. Some of you can look at this and be like, that's a 5. But when it comes to the really big equations, you will know what to do, all right? You will know how to guess. Let's say that was 15 over 16. Would you know what x is? Okay. So that's what solve and check really means. So here we go. We have t plus 8 equal to 0. Yes, you can have an equation equals 0. What are we going to do here? Opposite operation. That is subtract 8 from both sides. So t is actually equal negative 8 and so forth. So it's no difference if you have fractions. The good thing is here in these questions, your fractions already have the same denominator. So it makes life nice and sweet. So in this case, let's take a look at this problem. This looks like a sweet problem. So here we go. This is a fraction. It's a term. So the same rule applies. We're going to do the opposite operation, right? So this is c equals, so what's negative 1/5 minus 4/5? They are terms with like signs, so we're going to add and keep the sign. So this is actually negative 5 over 5, which is actually negative 1. That's why I like this problem. It's really witty, right? So this is another type of problem. As you can see, these are all simple equations that you see right now at this stage of the game. So here we just have equations that are factors, right? We have equations where our unknown are affected by factors. The first set of problems we were looking at, our unknown were affected by terms, all right? And it doesn't matter which side of the equation it is. You just look to see where your unknown is and do the opposite operation. So here, it's being affected by factors. So of course, the opposite of multiplication would be division. And in this case, we have fractions. The opposite would be the reciprocal, or you can do it step by step where you can multiply 3 to both sides and then divide by both sides. So like I said, just follow those guidelines of opposite operation. Look to identify your terms and factors. Let's see if your book gives you anything that has a combination of both. All right, so it looks like you're in luck. I didn't see a combination of both, at least in this stage of the game. This is for my pre-algebra introductory algebra students, and not for the students who are deep into algebra already. But they did provide an example where they ask, is a half or is some number a solution to an equation? And all you have to do is substitute that given number where your unknown is and work it out to see. So for example, if I substituted a half into x, I'll get 1 over 2 plus 3 over 2, which is 4 over 2. And 4 over 2 divided by 2 is 2. So the answer here would be yes. So right, you just substitute the given value where the unknown is. This is 4 over 2 equal 2, and that is a check. All right, until next time where we get into the big boy stuff. This is it for my pre-algebra introductory algebra students.